In this video, we're going to create a new Dataflow application that uses some operators that you haven't seen. First, we'll create a new project. Now we'll immediately go and begin creating a schema. And we're going to create a table schema for database table in the AdventureWorks database. Now, as part of creating the database schema, we can create the connection artifact. So there's actually no need to first create the artifact and then the schema. We can do them all in one continuous operation. So we'll enter the details needed to connect to the AdventureWorks database. And this will create both the connection artifact, and then we can use the connection artifact to create the schema. Once we have the connection artifact, it will be listed in the wizard for the schema creation. We'll select that connection and move on to the next window. Expressor reaches out, connects to the database, retrieves all the schemas within that database, and then displays the various tables within the schema that we've selected. We can select one or more tables to build a schema, or we can build schemas on a view. We'll just select the sales order detail table. Expressor suggests a name for the schema, which we'll accept. And then we open the schema for review. Now, notice how much richer this schema is than the schema from the file resource. On the left-hand side, you not only have the names of the database columns, but their types and sizes. And on the right-hand side, not everything is a string type attribute. Rather, the attributes are of appropriate types for the database column. Now, in actual fact, in this application, we're only interested in the line item total and the sales order ID values. We really don't want the other values, so we're going to create a second composite type in this schema, give it a distinctive name, and alter the content of that type by deleting the attributes that we have no interest in. Notice that the original type is still there in case we need to go back to it. So we'll select the attributes and delete them. Now we have a composite type that simply has two attributes in it, both of which we need for our application. Now we'll save the schema and we'll go on to create a second schema. This time we'll create a schema for the SQL query operator, which means we're going to write a select statement to retrieve exactly the results that we want. And the select statement can be quite complex. Here you see a select statement that's a join across two tables, extracting the column values from each table. We need to validate the SQL statement, which means Expressor actually goes out, connects to the database, and confirms that this is a valid SQL statement. We then move forward and we see what will be the structure of the result set returned from this query. And finally, we give the schema a name and save it. So now we have two schemas, one which selects all the columns from a database table, and the other which runs a specific select statement and gives us a return that we've defined. We're now ready to begin building our data flow. Now this one's going to be a little bit more complex. We're going to read from the two tables and do a join. So first we'll use the read table operator to read from the sales detail table. We simply configure the operator, being certain to select the right composite type. Next, we want to use an aggregate operator. What we want to do is sum the line item values for each purchase order. So to aggregate across the values, we need to select the aggregate key, which is the sales order ID, and then indicate to Expressor that the records are not in any sort of order, so it's going to have to maintain the calculations in memory. Next, we open the rules editor for the aggregate operator. And you can see that we need to completely define the structure of the output record. So first we add an attribute for the sales order ID, and we set this to an integer type. Next, we're going to add an attribute that will contain the total value of the line items. So we'll set this attribute to a decimal type because it's going to represent money. Once we select the decimal type, the various constraints valid for a decimal are listed. Now we're going to use a constraint to set the number of decimal places to 2. So we'll select that the maximum number of decimal places constraint, enter the value 2, and as a resolution we're going to say round. In other words, if the sum of the line items has more than 2 decimal places, the schema will round the value to the 2 decimal places. We will not have to do this in our code. So now we're ready to start adding the business rules. We simply drag from sales order ID to sales order ID. And since this is an aggregate operator, the aggregate functions appropriate to an integer type are already listed. And what we want is the first function. In other words, as each group of line items for a particular sales order come through, we want to select the sales order ID from the first record. Of course, this value is the same for every record. Next, we create another rule for the line items. Now, each line item is coming in with its total, and the appropriate aggregate rule is the sum rule. In other words, we want to sum up the values and get the total value of this order. And that completes configuration of the aggregate operator. Now we need to go back and put the SQL query operator into the Dataflow and configure it to read the result set that we get from our select statement. Next, we're going to join these two outputs so that our output record contains not only the sales order ID and the total of the line items, but also the name of the customer. First, we need to pick the join attribute from each incoming record. Now, they happen to have the same name, sales order ID, but that's not necessary. As you can see, you can pick any attribute from the 2 incoming records. We'll indicate that this is an inner join, and again, Expressor can do this in memory. And now we'll open the rules editor. And what you see here is the power of attribute propagation. Notice that the 4 attributes in the output record are exactly what we want, and that the right-facing arrow indicates that this data will be automatically and transparently copied from the input to the output by the attribute propagation functionality. So there's actually no code that we need to write in this operator. It's completely done for us. What we do want to do, though, is save the structure of the output record as a composite type, because we're going to use this, as we have before, in creating the schema for the output operator. So finally, we can bring the write file operator onto the Dataflow, connect it up, and configure it. Now we don't have a file connection, so we can create one right here, and we'll simply type in the location that we want the file written to, as opposed to browsing out to the file system. And we'll create the schema for the file by using the composite type that represents the record that will be emitted from the join operator. Once we do this, the only thing left to do is to give the output file a name, perhaps select if we want a header row put in or quotes around each value, and perhaps we want a timestamp included in the file name. So we complete the configuration of the Dataflow and we save it. Now we can do one other thing to make this application even better. And that is, we can change the mapping applied to the total sales order so that it's properly formatted. In other words, we want a $sign in front of the value, a comma after the thousands field, and a dot before the decimal places. So we open the mapping for this attribute, and you can see that we could specify the digits, but we've already done that earlier in the application in the schema. So at this point, we're going to select the Currency tab, and by selecting the Use Currency button and using the locale choice, we're going to get a $sign. If we were in England, we would get the £sign. And finally, we select the Grouping tab, and we specify that we want a comma used as the separator for every 3 places and a decimal point used before the cents value. We can close down the schema editor and run our application. Once the application runs, we can view the data, and it's exactly as we specified.